Okay, now I try to repeat one more thing. Okay, on display only. They said remember maximum modulation index is 1. 1 equivalent to 100% modulation. A signal that is over 100% modulated is said to be over modulated, which is an illegal condition. Over modulation distorts the information and cause excessive bandwidth to be used by the transmitter. Example, what is the percentage of the modulation correspond to a modulation index M of 0.5, and the calculation, okay, that equal 100 times M, you get 50% modulation. Definition and a measurement of the modulation index. Okay, AM modulation index can be defined by the formula M equal Vm over Vc, and a Vm that's just the information voltage, and Vc the carrier voltage. That's a general formula. However, when you display the wave, the AM modulation on the oscilloscope to measure the modulation index, then you have to using the formula M equal V max minus V minimum divide to V maximum plus V minimum. So if you see the display on the oscilloscope like this thing here, okay? First thing you need to know what is the V max. V max will be from here, okay, into the top here. Okay, and the V minimum from this part right here to the top right here. Okay, that's why they say V minimum here. So in order to do it, you have to count to see from the bottom to the top how many voltage, how many division. Like I can say 1, 2, a half, that means 3, right? 3 division for the Vmax. And depending on the scope setup, how many voltage per division. So that's why you're able to get a V maximum. And the V minimum you're looking in here, you can get what you think. How many division?
1.
They can be around 1. 1 division. Okay? That's how you can get V max and V minimum to apply to this formula. Okay, so any question on this page?
Mr. Pham, why it is illegal the overmodulation?
That means illegal condition. That means you will be jammed to the other channel. The thing is the signal transmitted over the air. Radio frequency.
Yep.
Each one get a different frequency. So when you get the over-modulated, they will be jammed into the other channel. So
Okay.
that's why they
Okay.
say illegal.
It's a kind of overlap between.
That's why.
Okay. Okay.
You only driving your car on your lane. Okay? Cannot in the middle between two lanes.
Okay.
Okay?
Thank you.
Yeah.
Then, Mr. Pham, for the FCC law says all devices have to accept interference. How do you account for that? Provide leverage or provide leeway in the signal for that?
What do you mean I provide what?
How do you allow for interference from other people's signals?
No, they're not.
Oh,
Absolutely. Not allow interference. Example. You want to build some circuitry transmitted over the air. Not mean you can do any frequency, no way. You have to looking on, in the previous page. They already telling you from what frequency to what frequency using for what. Okay?
yes.
So you must know what frequency you're supposed to allow to transmit your signal over the air.
That makes sense. I just got confused when I read my headphones and it says the FCC says you have to allow interference from other devices, so I got confused.
Okay. Now, you do it for me. By reading up to this point, hopefully you can answer the question. You understand our app will be very, very simple circuit. Only the thing is require understanding. Okay, they
CB
want to
radio?
read 3A application for AM. I given to you that thing. Oh man, they display everything. Okay, so that will be take your guy for a while to copy everything. Okay, they get the local broadcast, aircraft communication, and the software broadcast in high frequency bands. That's the three applications for AM. Why? FM and PM have to observe on an oscilloscope. A good, very good explanation to you. You can display AM modulation on the oscilloscope, but not FM or PM. They say since the information is 1 kilohertz and the carrier 1 megahertz, okay, that means 1,000 cycles of carrier played for every cycle of information. Since the oscilloscope is adjusted to show 1 cycle of information, it also sees 1,000 cycles of the carrier. The carrier sideways blend together forming a solid figure. That means you cannot display both your voice and also your carrier on the oscilloscope. The thing is when you display a low frequency, you cannot see high frequency. Or you can display for a high frequency, you cannot see your low frequency. So that's why you cannot display FM and the PM on the oscilloscope. And what instrument is preferred for measuring FMPM. That will be spectrum analyzer. Make sure when you've done it, let me know. The thing is when I upload for the PowerPoint, that means I allow you to typing on your document. This look like a handbook for you. Whenever you get interview for the technician job, you need to go through again.
Mr. Fan, for the carrier on, for the information, the voltage is what? Probably about 700 millivolts.
You mean the voice,
Yeah,
right?
about approximately.
Yeah, millivolt microvolt.
And the carrier, let's say 27 kilohertz. That's about what? 12 volts?
No, it can be just like a 5 volt or whatever voltage, okay? But
5 volts, 5 volts or lower or higher? What?
no, they can be uh, when we go into the next page, you can see a little more detail,
All right, thank you.
okay? Or if you see the picture we already saw it, then you can see the signal for the carrier, okay? Which one is the carrier and which one is your voice? Think if we get only 2 more weeks, then we can take a break. I already asked the city give me the permission in order to register for your guide the last week of this summer. We're telling you who will be on Tech 1, Tech 2. Most of the students start on the spring. Then we go to Tech 2. Hello. Hello?
Yes, Mr. Fan, go ahead.
Okay. Just circuitry for the AM modulation. Did you view it?
Like I said, that was the that was that breadboard from a couple years ago. That's your schematic. The only problem was the schematic I loaded up last night. I had to change one capacitor, and the potentiometer wasn't connected correctly. But then after that, like I was asking you the questions on the audio for millivolts and the carrier for voltage, I used approximately the I believe to be the same settings for the audio and the carrier to. It takes a while to get that modulation, but I believe I used the same settings to get the modulated frequency that you see.
The thing in simulation look very good to me. However, I said the true circuitry. That means the circuit we have to build.
The that information I sent you, that'll automatically design the circuit. It'll show you the circuit. Just have to import as text, and it will design the circuit automatically on FileStat.
The thing I get at one student right now, he's working on that. So I want to build and make sure we verify they're working exactly like your circuitry in the simulation.
You want me to find my breadboard? I have my breadboard. I can show you what show you it. I still have the original breadboard.
That's okay, but the thing I just want the schematic. And just,
Yeah, when you load that code in the FileStat, it'll automatically design the schematic for you. I can show you the schematic. Here, wait a minute.
okay, so we can talk about that later. You done for copy it?
Not yet, almost.
Okay.
Thank you.
Screenshot.
Same thing later, you have to write it down too.
I have a question, Mr. Pham. Regarding, I don't understand well, to be honest, I don't understand well question 4 and neither the answer.
Okay, let's say number 4. Why does the variable gain amplify state in the next sheet generate AM? And the answer will be when the information goes positive. The amplified gains will be followed. That means the gain will be increased.
Okay.
Okay? This causes the output voltage AM signal to swell or roll in amplitude. And also the opposite happens on the negative half cycle of the information. The AM signal will be synced. The thing is the gain now going down in amplitude because the amplified gain has decreased. Next page, that will be make more clear for you.
Next what?
Next page. Right now we're on section checkpoint.
Okay.
The next one, lecture, okay? Next page, following this page. After
Okay.
you guys done, I go to a next one.
Yes,
Okay.
I'm finished. Thank you.
Okay. Now, that one.
Okay.
Now, you can see this is the signal coming out of the modulator. Okay? So, try to understand when you're looking at the signal. Where is the carrier?
The blue.
The carrier right here.
Yeah. Yep.
That's just the sideway right here.
Yep.
Okay? That means any frequency here, that means carrier. that will be unmodulated. That means you don't see anything else, only this sideway at a high frequency. Okay? And when your voice will be here. You see that? That is your voice.
Yep.
Okay? When they go to the modulator, so the voltage for the carrier, they will be very with your voice. You see that? They keep going.
Yep.
Okay, so that's why they call it amplitude modulation.
Yep.
So when your voice going up, they going up, your voice going down. Okay? And they're going down and keep going. However, this is your voice here. And also you can see your voice right here.
Okay.
My question is, what the name when they go for that part here?
Envelope.
Very good. Envelope. That means your guy can read it. Okay? Envelope basically just like the voice. However, how come you get both? The regional modulator do that way. Okay? They can get both sides. Even you need only one side. You don't need a second side right here.
Yep.
However, modulator do it that way. We cannot do anything else. Okay?
Okay.
So that's what they call upper. That will be a lower. Okay? And now, they say support AM signal the V max peak to peak value read from reticule on the oscilloscope is 5.9 division and V minimum is 1.2 division. That means they're telling you from here to here 5.5, 5.9 division, and from here to here 1.2 division.
Mm.
They want to calculate the index, and you can say index equal Vm divide Vc. If you try to divide, can you get 0.662? You must do it. Make sure more clear to you.
Okay.
Is it correct? Is it a 1.2 divide 5.9?
I'm doing that. So,
The 0.5.
Okay, now, first thing, calculate that for me. What V carrier Vc equal?
I got to 1.5, Mr. Fong.
Yeah, but that is not the way. You calculate number 2.
Okay.
Count that first.
Okay, so that is 9 plus 2, 1. Okay, this is 3.5.
Vc 3.5.
Yes.
Let's see, I don't
Divided by 2
understand.
in there.
I don't understand how come they get 7.1. volt.
That's if you don't divide by 2.
You already get the formula V max plus V minimum divided by 2.
In the previous equation that you show, you didn't have the division by 2. You only write b max plus b minus, all of that divided by b max plus b minus, but you don't have the divided by 2.
That's
The-
the index.
V max, that means they want that we pick only a half. So that's why they divide by 2.
Okay, if you divide 4.7 divide by 7.1, that is 0.6619.
Okay, that's 0662. Now, if you're looking at a picture, what they define V max from here to here, right?
Yep.
So when you measure on the scope, they say pick to pick. That means they measure from here to here. Okay. So they want only from here to here. So that's why I divide by 2.
Okay, got it.
Okay. And then you get number 3, 4.7, and M you get 0.662. Okay, the second one. They want modulate index M by looking into this display right here. That will be more clear. And they said the scope will be setting 1 volt per division. Try to say what you get for the modulate index M. If you get the answer, let me know.
0.5.
First
Right?
of
Aren't
all,
we doing the second one?
Yet,
Okay.
so Mr. Pham, the divisions is what, 3 for the max and 1 for the minimum?
you mean for the second one?
Yeah, 3 for the max and 1 for the minimum.
I don't know.
Yeah.
Okay, yeah. So then it should be about 50%, which would be
I
0.5.
will say.
Yeah, 0.5, 50%.
They want M. They don't want modulation index. When they asking for percent modulation index, that you get a percent.
Yeah.
So what M equal? M will be equal VM
50%.
divide to VC. VM to volt. Easy to do, to recognize. 1 division, 2 division, 8 division 1 volt. So that's why VM is 2 volt. VC, that means will be 1, 2, 3, 4, 5, 6. Okay, 6 division. Plus VM2. That means you get 8. But you must be divided by 2. So you get 4. So 2 divided to 4, I think 50%, right?
Yes, sir.
Yeah. Make sure those pictures have to be make sure clear to your guy. That's all about AM transmitter. You can see this signal coming out from modulator and will be transmitted over the air until, to reach your radio receiver. And when they're coming out of modulator, you get both sides. Upper side, lower side signal. Okay? They call it double side. However, your voice, basically you need only one side, you don't need another side. The thing is when you transmit it, they need the power to transmission the signal. Then when you try to transmit double side, you have to spend more power. And now you can see, I don't need the second one. I only need the first one. So that's why they can get into another thing if they try to take a second one out before they transmit it. That's what they call a single sideband to say the power. Okay? Right now will be double sideband. Okay, any question on this page?
Mr. Pham, just on this one where you got the 6 plus 2 and 6 minus 2, that's for the peak to peak, right?
Yeah.
Because I mean, you could do it 3 minus 1.
Yeah, depend.
Yeah.
You're counting from here, up here. 6 division.
Mhm.
6 volt.
Mhm.
From here to here, 2 volt.
Mhm.
So V max plus V me, right?
Yeah, but I guess what I'm headed
Yeah,
toward,
depend. If you're using the V peak, then everything have to be V peak.
right, and then you would not have to divide by 2.
Exactly.
Okay, that's all I wanted to know. Thank you.
Okay, so M is 50%. Okay, this is the same thing. They will show you a few things. This signal here, that will be 100% modulation. 100%. You can see on this part right here. Very small. Okay? And that's what they call over modulation. What is the difference? When you look in the signal, you're able to recognize is it a 100% modulation or that will be over modulation.
Is it that the one on the right is overmodulated because it's the end of it is like a line or something?
Right, exactly. That look like a line. Very long. Okay? That is 100%. But that will be, when they flat right here, they will be over modulation. What they said in here, the intelligent voltage is too large for the carrier. That means your voice, the voltage is larger than the carrier voltage. First, the envelope is no longer an accurate copy of information. The second thing, excessive bandwidth that will interfere with adjacent station. Okay? Very good explanation for you. Make sure you keep reading, okay? Okay, now they're talking about frequency domain in the spectrum analyzer. In this domain, it is easy to measure the bandwidth and the total power of the AM signal. On that one, they display on the spectrum analyzer. That will be frequency domain. Okay? And that will be unmodulated 100 kHz carrier. So basically they display for you the carrier at 100 kilohertz and the value will be 10 volt. You didn't see any sideway, anything, any square wave. They just telling you at a certain frequency what the amplitude or the value of the signal. Okay? Now, in the second one, figure 311, the 100 kilohertz carry modulated with 5 kilohertz information. So if you're reading on that thing, you understand FC equal 100K, right? And FM equal 5K. Okay? So in display in here, first thing they display for the carrier, 100K. Okay? And the amplitude will be 10 volt for the carrier. However, you didn't see any 5 kilohertz in here. You see that? The thing is 5 kilohertz. Okay, when they go to the modulator, they get the upper sideband and the lower sideband. So the upper frequency will be 100 plus 5. So that's why you get 105 kilohertz. Okay? Upper sideband. upper sideband or upper side frequency. And on that one will be 100K minus 5K. Okay? So, lower sideband or lower side frequency. And also they telling you the value of upper side or lower side will be 5 volt. So that will be displayed on the spectrum analyzer. Okay, now I get a question if you're looking on that display. What is the bandwidth?
And kilohertz?
What is the bandwidth?
In kilohertz.
10 kilohertz.
10 kilohertz. How do you get that? You understand that the bandwidth will be from here up to here. You take 105K minus 95K. That's what you get the bandwidth.
F2 minus F1.
Yeah. F upper sideband minus F lower sideband. So you guys get any question on this page?
Yes, please.
Yeah.
So figure 311, it says there's a 100 kilohertz carrier and the modulated part contains 5 kilohertz of information.
Mm-hmm.
So does that mean that we have to provide enough amplitude for the
No, you measure, it's not you provide.
I mean, so does the amplitude of the carrier wave have to change for how much data is given for the intelligence wave?
No, the thing is when you measure for the carrier, then you're supposed to get a carrier voltage.
So the slope for the roll off will get worse the more data you put?
What do you mean the more data?
Like for the frequency response when it comes back and gets undone and given to the receiver side?
No, we're not talking about receiver.
Okay.
Right now we're on transmitter. We don't want confusion. Okay?
Are we going to talk about clipping? Is that something that happens with it?
What?
Clipping, like if your signal is too high, your receiver can't reproduce the correct frequency.
Yeah, if you already read it, that means you get a distortion, you get something wrong when your intelligent voltage higher than the carrier voltage.
Okay.
Okay. Frequency domain divided. On the figure 3.10. On that one, they just explained what I already telling you. So 100K sideway in the frequency domain. How do we know this is a sideway? Since there is only one frequency present, 100 kilohertz. The sideway is the only pure waveform and it contains only one frequency. What happens when this carrier signal is amplitude modulated? In the frequency domain, the rapidly changing amplitude shows up at the new frequency called a sideband. Sideband are new frequency generated during the process of modulation. They are created by nonlinear distortion introduced by the modulator amplifier. All modulation create a sideband whether it will be AM, FM, or PM. Suppose that a 100 kHz carrier is amplitude modulated by 10 volt, 5 kHz information signal. The result frequency domain picture will look like in the figure 3.11 that I just showed you. What are the sideband? The 5 kHz information signal seem to have disappeared in the display. In reality, the information energy 5K has been transformed into sideband energy 95K and 105K. The sideband contain the information. Okay? So they given you F upper sideband and F for lower sideband. That's what you keep reading it, okay? Too many times, hopefully you're able to understand. Okay, let's see 311 here. We already know everything in here. Okay? V upper sideband equal V lower sideband equal Vm divided Q. Example. Calculate the bandwidth and modulation index of AM signal so. I believe you know how to calculate the bandwidth, right? We already know 100, 105 minus 95. And now you already tell me the index M. You can tell me how many percent of the modulation.
%.
That's what answer.
%33%.
Look into the answer.
Uh-huh.
When you calculate the VM, you have to calculate both sides. One side 5 volt. Both sides will be 10 volt. So that's why in here you can see I given you V upper sideband equal V lower sideband and equal Vm divided by 2. So if you want to calculate the Vm, you have to take your time, either upper side or lower side. Done? So you done on this page?
Yes.
Okay. Now, that's what you need to do for me. For the AM signal show here, they want to calculate first thing, the information frequency FM. The second thing, voltage in the upper side band, the bandwidth, and that means modulation, index modulation. So try to see how many people can do it. If you get a perfectly 100%, that tell me you really understand it. Anyone done, let me know.
Done, but it's probably wrong.
I don't care. We'll see. But you get 1, 2, 3, 4.
Yeah.
Okay, let's see what we get. $3K. You get that? Number 2 will be easy. What is the value of the upper sideband voltage?
5.
5 volts.
35.
5 volt, right? They have to be the same with the lower.
So, Mr. Pham, for number 1, you weren't looking for 807 kilohertz. which is what the frequency would actually be. You were looking for the difference between the two, right? Just to be clear.
I'm looking for information frequency, your voice. Your voice not show up here on the display, right? However, if you already get a upper frequency 813 and you get a carrier 810, you take 813 minus 810, that's why you get 3K.
Got it. Okay, thank you.
The bandwidth,
6 kilohertz.
6K.
we say 6, right? Bandwidth will be 6K. That's what they telling you here. F max minus F minimum. F upper sideband minus F lower sideband. Make sure you understand and you can do calculation quickly. Normally when they interview you, this is the one very simple. You ask the question. Not involve too much thing. Only thing is they asking for your knowledge. And who get number 4?
Is it 33%?
VM will be 2 times upper side or lower side. That will be 10 volt. 10 divide carrier 20. You get 50%. You see, this is a very simple calculation if you understand. Hopefully, next meeting, next time, I given you a problem, you can get through 100%. Complete calculation. That will give me happy to keep going. Otherwise, you're not reading, you're not understanding. Just waste my time.
Mr. Van, any chance that you move one slide back to write down something that I missed, please?
Going back. Okay, after they done on this one.
Okay, thank you.
Mr. Pham, I have a question.
Yeah.
So VM, is that voltage modulated? And
That's your information.
Carrier?
VM means voltage of the modulation.
And VC is voltage carrier?
No, it's not carrier. VC carrier.
Yeah, VC carrier.
VM, that means your voice.
Right. So we're dividing voltage modulated by voltage carrier. If the modulation is single band, then you don't multiply it by 2?
Yeah, the thing that they will be both sides. Okay.
In this case.
So now I just going a little previous here. Okay. I go previous here.
Right, because this is the double-sided band.
Yeah.
But that's why we're multiplying it by 2.
Right.
Okay.
They both side, not one side. Okay? So the one asking me which page you want. Is it this page?
No, the other page is fine. I understand. I'm just
Okay, that's good.
putting better together the information.
Okay, so you're done for this page, right?
Yes,
Make
thank you.
sure I said you must be copy it, okay?
Yes.
Otherwise, just waste the time in the program. I want you to understanding like I do it. You want job skill, you want get paid more, then you must be study. Nothing for free. Except you in this program, you don't have to pay a penny. Myself, I already retired, so I teaching for fun, okay? So that's why. Okay, so we go next page. Okay, now you do it for me this page. Certain AM signal. Okay, get VC 100 volt FC 2182K VM 25 volt FM 2.5K. What the bandwidth required by the signal? What is the modulation index M and the percentage of modulation? And they want to say draw the program of the signal so on the voltage. Number C look like we already draw for you. Only thing you need to know what the bandwidth required and the modulation index. Who get the answer, let me know.
Is the bandwidth 5K?
5K.
Okay, I don't know, we'll see. No, I forget everything.
25%.
Very good. 5K.
Point 25, 25%.
25%.
Perfect. Okay? And that's what we already draw right here for you. they said draw spectrogram of the signal cells on the voltage. Okay? Now, maybe we get one more page. In order to draw the spectrogram, we modify the sideband, frequency, and the voltage. That's what you need to know. What the voltage here, voltage carrier here, what the sideband frequency, upper side, lower side, and the carrier. So next time when we asking you to draw, you're able on how to draw it. In order to get a V up sideband, low sideband, then you have to take a VM divide by Joule. And also they given you the formula to get a frequency upside band, FC plus FM, and a lower side will be FC minus FM. So that's why we come up with that number. After you're done for this page, let me know. Try to get on the note, okay? Otherwise later on you don't know how come you get 12.5 volt. How come you can get 2184.5K, okay? Or 2179.5 kilohertz. You done?
Almost. Yes, I'm finished. Thank you.
Okay. Okay, so we quick get through that one and we'll be stop power and efficiency. Watt meter is using to measure the power being produced by a trend meter. So basically you get a DMM. DMM only measure the voltage, the current, DC-AC. And sometimes they can measure the frequency and they can measure the capacitor inductor. However, they cannot measure the power. If you want to measure the power, then you have to use using watt meter. Just a minute, okay? Hello?
Đọc dùm số để đi vào bộ được không? Đi vào bộ thách á.
Okay, chờ chút coi.
Dạ.
Tám chín hai không. Ok, có đăng dạy mà. Okay, so we have to using the watt meter to measure the power, okay? Not the DMM, not the oscilloscope. In the frequency domain, AM consists of carrier frequency, a pair of the sideband that we already see, upper sideband, lower sideband. So the total power is the sum of all the individual power in the signal. So in order to calculate the total power, then you have to take the power of lower sideband plus the power upper sideband and plus the carrier power. Okay? Antenna is a transducer. It accepts RF energy from transmitter and converts it into electromagnetic energy. A resistor is also a transducer. It converting electrical energy into the heat energy. Energy goes into the antenna and doesn't return to the circuit. It appears as pure resistance. Okay? So make sure you must be reading this so the next meeting more easy for me to explain to you.
Hey, Mr. Pham, in the lab, do you have watt meters?
What?
Do you have watt meters in your lab?
We already bought it, but they not come yet.
Oh, okay.
That cost more money. Not like DMM.
Is that a device?
What?
Is that a device? What better is the device to measure?
What do you mean divide?
like a
Just a
DMM.
meter
But
like DMM. But
oh,
when you measure
I
the power,
never see that. I never see that.
yeah, you never see. The thing is, that cost much money. We already order, but then we get the virus. Everything really slow.
So now that they have the coronavirus, they're going to take the money back, right?
They have to do something. So now, right now, no one go to the office, so nothing can be happen. Nothing can be done.
Can you explain the last bullet point?
I didn't hear you. Can
Can you
Mr.
explain the
Smith?
last? Can
Yeah,
you
she
explain
said,
the
she
last?
said, can you explain the last bullet point?
What? Can you say again?
She wants you to explain the last bullet point.
The last on this page, right?
Yes.
Okay. So now they telling you, okay, for the transmitter you get carrier transmitter, and you get a side band also transmitter. But the side band you can get both upper side and lower side. So if you want to calculate the total, okay, of the power, then you have to adding power of the lower side band plus power carry and also plus of the upper side band. Okay? Now, first thing, what you understand for transducer? What that mean? Transducer.
It converts one energy to another, or one.
Right. Converting one energy to the other. I given you example. When the current go to the resistor, when you turn on your headlight, when you touch into the front, you feel hot. Okay? So basically that converting electrical into the heat. That kind of the transducer. Okay? So in here, they say antenna is a transducer. Okay? It accepts RF energy from transmitter and convert it into electromagnetic energy when they transfer. And also a resistor, also transducer, like I just talked to you. It converting electrical energy into the heat energy. Energy goes into the antenna and doesn't return to the circuitry. Like the current go to resistor, they turn out to the heat. That everything will be lost, cannot recover. Okay? So they said energy, just a minute. They say energy got into antenna and doesn't return to the circuit. It appears as pure resistance. Okay, so what question?
So this last piece, when we're talking about energy, we're talking about the heat energy.
Yeah, they same thing like heat energy. That means energy they say got into the antenna and they cannot be returned. Look like the same thing like pure pure resistance. That's it.
Okay. Thank you.
Okay? Yeah. So uh, I can stop sharing now. And any question, anyone want to share something?
Hey, Mr. Pham, that RF energy is so powerful that it can burn a person pretty good. Is that correct? If not operated properly?
Just a minute. I want to see something on my outcome. Okay, just a minute.
I think, Mr. Smith, I think it depends on time of exposure.
Yeah, I was just thinking about that because some years ago, a TV person was talking with the mic, and she got up on like like these TV channels. They have trucks with their antennas and all that stuff on it, and something happened, and the RF cable hit her, and she lost her hand. I was thinking that the heat must be pretty tough on those.
Maybe. That's an interesting question.
Okay, anyone want to share anything?
Mr. Fama, I want you to ask a question. How this transducer called antenna transform the RF energy into electromagnetic energy? How that happen inside of the antenna?
Outside, when they're going out, coming out. Yeah, that's the job of antenna.
Yeah, but how that happen? The example about the resistor that transform electricity into heat, I understand perfectly fine, but how that happen in the antenna, how the antenna transform RF energy into electromagnetic energy.
That means
Isn't RF electromagnetic energy anyway?
after they get out, the antenna. That is how they convert it. Okay.
Okay.
They say antenna convert electrical energy. So if you're reading next page or after next page, you can see we get example to get more clear to you.
Okay.
Another thing to do research on is the ability for a phone to charge itself on a transducer power pack. That transference from coils to coils, or that field that is generated between the phone and the transducer, like a wireless connection. That's something to do research on. That'll help clarify that question. Because you're laying something on top of something, and they're transferring energy. So it's that space in between. That's the question that you want to answer. So you have to understand how that the transducer is communicating with the phone, right?
Right. Okay. So when
another thing too, Mr. Fram, I have
we'll
that
see.
schematic.
We'll see
you want to
guys.
screenshot it?
We'll see you guys tomorrow.
I have the screen. The screen.
You
want a screen?
You want to share, right?
I guess you can get a screenshot if you want. Ready?
Okay.
Mr. Pham, tomorrow, are we continuing with this? Or are we doing something else?
That's what I'm thinking. What you guys want?
What are the options with something else?
You can go with it, or you can want to be.
I would like to learn more about RF if it's possible.
Okay.
If it is possible, that's
no,
the case.
No problem with me.
Marcelo, look at your chat.
Thank you.
Marcelo, look at your chat.
Thank you, Catherine. Okay, cool. Thank you.
Okay, let's see. How can I copy this thing?
The screenshot.
Okay, screenshot. Okay. I already copy it.
That's the original, one of your original schematics right there. I tried to run it. I tried to run it in PSpice, but you don't get the modulation signal. But you can run it in MSIM. MSIM's all right.
Okay.
And then that's the same one I'm using for Faustad.
Okay, no problem. Okay, so good night.
Night, Mr. Frank.
Night. Thank you.
Good night.